Welcome to the video from Verde Tech Design and BIM Solutions, where we're transforming ideas into intelligent spaces. Smart planning in green buildings goes beyond the building envelope and extends to sustainable mobility and transportation strategies. One of the key objectives is to reduce dependence on private vehicles, which directly helps in lowering fuel consumption, traffic congestion, and air pollution. This is achieved by encouraging access to public transportation, such as buses, metro stations, and shared mobility options within walkable distances from the project site. Locating buildings close to essential amenities, including offices, schools, healthcare, retail, and recreational facilities, further reduces the need for frequent vehicular travel. Walkable and bicycle-friendly infrastructure also supports healthier lifestyles while reducing carbon emissions. In addition, green buildings promote the transition to cleaner modes of transport by providing electric vehicle (EV) charging infrastructure within parking areas. Installing adequate electrical charging points supports the use of electric vehicles, reduces dependence on fossil fuels, and helps prevent unnecessary fuel wastage. It also prepares the building for future mobility needs as EV adoption continues to grow in India. Such measures not only improve environmental performance, but also enhance occupant convenience and long-term sustainability value of the project. These strategies are often recognized and rewarded under IGBC rating systems as part of site sustainability and energy efficiency credits. Therefore, smart planning integrates sustainable transportation, EV readiness, and proximity to amenities to create low-carbon, future-ready green developments. The third area is about a lighter footprint, focusing on efficiency in water and energy usage. Water efficiency and the rainwater journey. Water efficiency in green buildings is achieved through a structured approach known as the rainwater journey, which treats rainwater as a valuable resource rather than a waste product. This journey focuses on three key stages: collection, volume management, and reuse, to significantly reduce dependence on municipal water supply. The first stage is collecting runoff. Rainwater falling on rooftops, terraces, and other hard surfaces is captured through well-designed drainage systems, such as gutters, downpipes, and catchment areas. Proper filtration at this stage helps remove debris and improves the quality of collected water. The second stage involves managing the volume of rainwater. Uncontrolled runoff can lead to flooding, erosion, and overloading of municipal stormwater systems. To address this, green buildings incorporate storage tanks, recharge pits, percolation trenches, rain gardens, and bioswales. These systems help regulate peak runoff, enhance groundwater recharge, and maintain the site's natural hydrological balance. The final stage is reusing the collected water for suitable non-potable applications, such as landscape irrigation, toilet flushing, cooling towers, and housekeeping activities. By reusing rainwater within the project, the demand for treated municipal water is substantially reduced, leading to lower operating costs and improved water security. These strategies are aligned with IGBC water conservation credits and support national objectives for sustainable water management. Checkmark. In essence, the rainwater journey converts rainfall into a managed, reusable resource, helping buildings become more water efficient, resilient, and environmentally responsible. Healthy buildings, materials, and occupant well-being. The fourth topic, healthy buildings, emphasizes creating indoor environments that actively support the health, comfort, and well-being of occupants, recognizing that people spend a significant portion of their time inside buildings. A truly green building is not only resource efficient, but also safe, comfortable, and healthy to occupy. A key focus area is the selection of materials. Green buildings encourage the use of non-toxic, low VOC, and environmentally responsible materials such as paints, adhesives, sealants, flooring, and composite wood products. These materials minimize the release of harmful pollutants, improving indoor air quality and reducing the risk of health issues such as respiratory problems, allergies, and long-term illnesses. In addition to material choice, occupant well-being is supported through good indoor air quality with adequate fresh air ventilation, thermal comfort, ensuring appropriate temperature and humidity levels, visual comfort, achieved through daylighting and glare control, acoustic comfort, reducing noise disturbances, access to daylight and views, which positively impact mental health and productivity. Healthy buildings also address policies and practices, such as smoking restrictions, maintenance of ventilation systems, and regular monitoring of indoor environmental parameters. Within the IGBC framework, These strategies are evaluated under Indoor Environmental Quality (IEQ) credits, ensuring measurable performance and third-party verification. Checkmark. In summary, the Healthy Buildings concept places people at the center of design, ensuring that sustainable buildings enhance both environmental performance and human well-being. Materials and waste management focus. This approach also places strong emphasis on construction waste management, which is a critical component of sustainable construction practices. The primary goal is to divert at least 75% of construction and demolition waste from landfills by adopting systematic methods for reuse, recycling, and responsible disposal. Effective waste management begins with segregation of waste at source, separating materials such as concrete, steel, wood, glass, plastics, and packaging. These materials can then be reused on-site where possible or sent to authorized recyclers, significantly reducing the burden on landfills and lowering the project's environmental footprint. In parallel, green projects prioritize the use of smarter and greener materials. This includes materials with recycled content, locally sourced products, rapidly renewable materials, and products with low embodied energy. Preference is also given to materials that are durable, low maintenance, and have minimal environmental impact across their life cycle. By combining waste reduction strategies with responsible material selection, projects not only conserve natural resources, but also reduce emissions associated with material extraction, manufacturing, and transportation. Thus, construction waste diversion and the use of greener materials are key strategies in achieving resource efficiency and higher IGBC rating performance. Indoor air quality and materials focus. Material selection in green buildings plays a vital role not only in sustainability, but also in maintaining high indoor air quality, IAQ, which directly impacts occupant health, comfort, and productivity. Many conventional construction and finishing materials release volatile organic compounds, VOCs, that can cause respiratory issues, headaches, irritation, and long-term health problems. To address this, green buildings encourage the use of low VOC or VOC-free materials, including paints, coatings, adhesives, sealants, flooring, carpets, and composite wood products. These materials significantly reduce the release of harmful pollutants into indoor spaces, creating a healthier and safer environment for occupants. In addition to material selection, proper ventilation is essential to ensure continuous fresh air circulation. Adequate ventilation helps dilute indoor pollutants, remove contaminants, control humidity, and maintain acceptable oxygen levels. This can be achieved through natural ventilation strategies, mechanical ventilation systems designed as per standards, or a combination of both. Regular monitoring and compliance with prescribed ventilation rates further ensure that indoor spaces remain comfortable and hygienic. These strategies are integral to indoor environmental quality credits in IGBC rating systems. In summary, thoughtful material choices combined with effective ventilation systems are key to enhancing indoor air quality and supporting occupant well-being in green buildings. The fifth area, designing the future, emphasizes innovation in sustainable building practices. Innovation earns points for performance not specifically addressed by the IGBC system, encouraging us to imagine the green building of tomorrow.